Yeah, so we were, and so the name was not correct here. It was actually the sliding friction that I was talking. So we have sliding and then you have rolling friction. Okay, this is sliding, but not the impending. Okay, and in NCRT it is written as normally as friction. So sliding word is not there also, but we can generally say that that is a sliding friction. Okay, so let us quickly recap this and then we can go ahead. So, Rishita, we were talking about, so in when you left, we were talking about friction. What is a frictional force? Right. So, what is friction? So, I gave an example that let's say some car is moving on this road, and then the engine has stopped. So you stopped it. So it was moving with, let's say, 30 kilometer per hour, right? And what you do is that you stop the engine. Then what happens is that this car will move to some distance, right? And then it will stop. So we are seeing that it is violating the law of inertia because it had some initial speed, but it is not continuing with that speed, right? It is violating the law of inertia, but that shouldn't happen. When the law of inertia is violated, when the external force is applied, right? So then we argued that, or then we concluded that there must be a force which is opposing the relative motion of this car, right? And that opposing force, we call that as friction, right, everyone?
Yes, sir.
Yes, sir.
So this happens between the layers or between the surfaces of two objects, right? So let's say that, right. So let's say that I have this surface. I have to pin my, okay. So I have these two surfaces and then they are attached. So if I am moving this surface, right, I'm moving this surface in the downward direction, which means that this surface is applying some force in the upward direction to oppose the motion of this object, right? Similarly, if I put the object in this way, and if I move the object in this direction, so this surface will apply the opposing force in this direction. So depending upon the relative motion of the object, the other solid surface will apply an opposing force, and that we called as the frictional force, right, guys?
Yes, sir.
So similarly, in fluids, so these are solid surfaces, right? So similarly, if you have some liquids or the fluids, then the layers of the fluid also apply some frictional force, and that is called the viscosity. So then we understood that there are two kinds of friction, right? First, we wrote that it is an opposing force act which which acts between the two surfaces in contact to oppose the relative motion, right? So, and it has two kinds. So, kinds of friction. First was in the solid surfaces. So that was we called as friction. And in the so this in between solid surface. Okay, and then we have the viscosity, which happens between fluid surface. So that is why you guys have seen that the honey, the water, the oil, these have different kinds of properties. So if you put a coin in honey, if you put a coin in water, if you put a coin in let's say oil, so they all experience some different frictional force, and that is because of this viscosity. All these fluids will have different kinds of viscosity, right? Okay, and then we understood that this has, right, again two kinds. One was the which I wrongly wrote, so this was sliding friction, right, and the other one is the rolling friction. So if the objects are sliding on the surface, then it will have sliding friction, and due to rotational effect, right, due to rotational effect, we will have some rolling friction. So these are the two kinds of friction, and then I talked about that the sliding friction has also three types, right? One was the static friction, and then we have limiting friction, and then we have this kinetic friction. So as the name suggests that let's say I gave the example of arcade moving a sofa, right? So let's say this is some sofa, right, on the surface, and arcade was pushing this sofa, right? So we saw that let's say initially Akib applied 10 Newton force, right? Then what happened? This sofa didn't, which means that it also applied some opposing force to uh, to obstruct the relative motion of this sofa, right? And that is also equal to 10, right? And let's say that Akib applied much effort, so increased his effort, and he applied, let's say, directly 40 Newton force, right? Then this object moved a little, right? So then this is the different force. Then this is not a static force. So up to which point the sofa didn't move, so that kind of opposing force is called the static friction. Whenever the object is not moving and when we are applying the force, which means that the object is applying the frictional force, right? The object is experiencing the frictional force. Okay. And whenever we reach that particular point, when the object starts to move, so that is called the limiting friction, right? So that is the maximum static friction that a body can have, right? And when the body starts to move, then it will experience, so then this body is moving, so then this will experience some static friction. Okay. Earlier it was experiencing static friction, right? And it reached a certain value, limiting friction, and after limiting friction, the friction will change to the kinetic friction. So these are the three kinds of static friction. These kind of three kinds of sliding friction, right? So then we were defining these three kinds. So static friction. So friction experienced by the object when the object is stationary, right? And we also know that it is dependent upon, it is dependent, it is dependent on the normal reaction. Okay. And it does not depend upon the area of contact. It does not depend on the area of contact, and it only it depends on it depends on the roughness of the surface. Okay, so let's say that you have this kind of surface, right? And this kind of surface. So this will have less friction, and this will have a larger value of friction, right? Okay, because this
Yes,
has,
sir.
yeah, because this has a greater roughness. Okay, so this was about the static friction, right? And then we have this limiting friction, limiting friction. So it is the maximum, or this was also one point I also mentioned in the static friction was that it is an adjustable force, right? So if you apply a 20 Newton force, then the object will apply the same amount of force. If you apply 10 Newton force, then the object will apply the same 10 Newton force, right? So that is why this is an adjustable force. Depending upon what force you are applying, so that static friction can change, right? Okay, so the next is, what is the limiting friction? So it is the maximum static friction after which the object starts to move, right? So this friction tells us that how much force we should apply on the object so that the object starts to move, right? And this is also dependent upon, this is also, so as you can see that this is static friction, so this is also dependent on the normal reaction, okay, and it also does not depend on area of contact, and it also depends upon the roughness of the object. This is the theory part. So how do we represent? Right. So we have this limiting friction, and this is directly proportional to the normal reaction. So let's say that if we have an object in here, right, and you are applying a force, okay, and you get a maximum value at which it just starts to move, right? So it is called the limiting friction, right? And the normal reaction that this object experiences is that, okay. So this is equal to what? This is let's say if you remove the proportionality constant, then you will get mu L. And so this is called the coefficient of limiting friction.
Sir,
Okay,
is it FL?
yeah, this is FL, limiting. So L
Okay, sir.
means limiting. Okay, so you guys note down this part because static part we did. You guys please note down this limiting
So,
friction.
in limiting friction, the last point, it also depends on the roughness of the object. Is
Yes.
it object or surface?
Oh, so roughness of the surface and the object as well. So let's say that object is rough, right? So then it will have some, yeah, so we can also write that surface. So surface meaning both the surface, right? It is a relative thing. So if both the surfaces are rough, then it will have some greater amount of limiting friction, right?
Yes, sir.
So always remember that this friction is a relative thing, right? So both the surfaces we are counting. Okay. And yeah, what is the cause of this friction? So the cause lie in the intermolecular forces. So we have, right, we have this object. Let's say this is microscopically. So very small when we have a very magnifying glass. So from magnifying glass, we see that both the objects, so this will have these kind of surfaces. So they will interlock each other and then they will apply some frictional force. So when they will interlock, which means that they are bounded, right? So when you try to move this object, then you have to break this bond. So that is why you experience the friction because of the intermolecular force of these two surfaces. Okay, but that part, yes, that part we just
Sir, it also depends on the heaviness of the object. Like,
which roughness.
like
May what did you
it's
say?
the friction. Like, if an object is more heavy, will there be more friction?
So you see that if you are putting it in this way, right? Heavy meaning you have more mass, right?
Yes, sir. Yes, sir.
So you see that we will see that how the weight is there. So we'll see that. We'll see that how weight is dependent upon. So how friction is dependent upon the weight. So it may or it may not depend upon the weight. Okay.
Yes, sir.
Okay, we'll see that. We'll see that.
Finish, sir.
Finished. Okay, Rishita, Amna, and Ilham, what about you guys?
Done, sir.
Yes,
Done.
sir, finished.
Okay, so and the next thing is kinetic friction. So I'm just writing the theory part, and then we'll do numerous questions. So next is kinetic friction. So the friction between the surface experienced when the object starts to move. Right. So not starts to move, but object is okay. So you have, let's say, you have this object, and it is moving with some acceleration or velocity or whatever. Right. Then it will experience a kinetic friction. So this kinetic friction is also dependent upon the normal reaction, and if we remove the proportionality, then we get this. So this is the kinetic friction. Okay, and always remember that this limiting friction is always greater than this. So this coefficient of kinetic friction. So this is always greater than this kinetic coefficient. Okay.
Yes, sir.
Now we'll start with a simple question and then we'll complicate things. So now let's say that you have an object, and this will tell your answer, Ilham. You ask the question that is it dependent upon the weight or the heavy, right? So so you see that let's say the mass of this object is 4 kg, right? And the force that you are applying in this direction is let's say this is 50 Newton. So and the coefficient of limiting friction is 0.5. Okay, so this is the coefficient, and you can see that what would be the unit of this coefficient. So Fk is mu k and n. So mu k is Fk by n. So what is the unit of this force, frictional force? What is the unit of frictional force? Hmm. Force. What is the unit of force? Yes, guys, unit of force.
Newton?
Hmm.
Newton.
Newton. So why you guys? Okay, so this is Newton. And what is the unit of normal reaction? Yeah,
Newton.
what to Newton? Because this is also common force. When we studied common forces in nature, so we studied this new normal reaction. So this is also Newton. So this cancels, so which means that mu k is unitless, right? This is unitless, which means that it is dimensional. Okay, we didn't do the dimensional first unit, right? So I have to do that chapter also. Okay, I will see that. So I'll have to take the extra class and complete this first chapter. The first chapter is pretty easy. First chapter is about dimensional analysis and error analysis. So that will take only two classes. So I will take that class at some point. Okay, so
Yes, sir.
let us get back to the question. So Akib is pulling this object, 4 kg object, and he is applying 50 Newton force. So this will experience a relative right force in this direction. So let's say that what is the limiting friction, right? So you guys calculate and tell me what is the limiting friction. Oh, but you already know that FL is mu L and N. So you guys calculate and tell me how much FL you are getting. Because we have done free body diagrams, we have done the common forces in mechanics, but then this should be easy. Let me write it as, oh, so already 25. Akib got 25. Let me write it as, first let me write it as 20. Okay, Amna also got 20.
Even I got 25.
So Aram, you are also getting 25.
Yes, sir.
Okay,
Sir, I will.
okay. So Rishida, you same.
Yes, sir.
Oops, everybody got 25 Newton, right? Good. So this is FL, right? And this is normal reaction. And this would be equal to what? This would be equal to this, right? Mg, which is 4g. So N is 4g, which is 10, which is 40 Newton, right? And FL is mu L, and this is 40. So which means that mu L is how much? 0.5 and 40. So so how much, guys?
I used 50 for Newton.
No. So this we cannot use, right?
Yes, sir.
Because this frictional limiting friction is dependent upon this normal reaction only. So it doesn't depend upon this. This will tell you that whether the object will move or not. Okay, I'm getting 20. So let me write it as 50. So did you guys understand that why did I get 20 Newton?
Yes, sir.
Yes, sir.
Okay, so now you guys say that this object, this object is experiencing a static friction of 20 Newton in this direction, right? So, and you are applying a 15 Newton force in this direction. So, will this object will move? Will the object?
Yes.
So, you are applying a 15 Newton force,
Then
and
no.
this
No, sir,
object,
it won't.
right? Because this is the maximum static friction that you can have,
Yes, sir.
right? So, the object will not move. Okay,
Sir, it will move when it will be greater than 20, right?
absolutely right. Yeah, so that is what I wanted to come. Good. So, okay. Yes, absolutely right. So, but you guys first note down this problem. Okay, so the FL is greater than F, which is 15 Newton. So object will not. So this limiting friction decides that when the object will move or not. The object will not. You guys, please note down this problem. Okay, and you guys, if you guys have any doubts, so please ask.
No, sir. Finished, sir.
Finished. Elam,
Done.
Amna, Rishita.
Yes, sir, done.
Yes, sir.
Amna, what about you?
Done, sir.
Okay, so Elham, answer to your question. So in this case, we saw that this normal reaction was dependent upon what?
Mass.
Mass, right? So in this case, we can say that this limiting friction is dependent upon the weight. In this case, right?
Yes, sir.
But let's say that the object is in here, right? Object is placed in here. So you are applying some force and the object is here, right? So in this way, the friction it will experience is in this direction, right? So yeah, so in this case, the to object to move, yeah. So in this case also, it will have yeah. So it will have a weight in this direction. So in this case also, it is dependent upon this mass, right? So
Yes, sir.
what I am saying is that yeah, but in certain cases, you see that this normal reaction is not equal to this mg, right? In this case, so let's say this is the force that you are applying. What is the normal reaction to this object? In this case, is this mg. Yes.
So, same direction as the friction force.
So are you saying that normal reaction is in this direction? What is
No,
the
sir.
where is the surface? Where is the surface? Whenever we talk about normal reaction, we see the surface in the contact, and normal reaction is perpendicular to that surface.
Yes,
So
sir.
so let me show you guys. So what do we have? One moment. So let's say this is the surface, and these two surfaces are in the contact, right? And
Yes,
you are applying the force. So this object is not moving, right?
yes, sir.
Due to this force. So you see that normal reaction, these are the two surfaces, this one and this one. So these surfaces are in contact. So what would be
Yes,
the
sir.
perpendicular direction to that surface? What would be that? It would be upward or right.
So,
So
right.
right. So this would be the normal reaction. So normal reaction would be equal to this force that you are applying. Understood?
Yes, sir.
Okay, so yeah, but as you were saying that this frictional force is dependent upon this mass or this heaviness of the object. Yeah, so you are correct. Understood? Okay, but the normal reaction could be different, right?
Yes, sir.
Okay. So, but in this case, right, in this case, this frictional force is not dependent upon this weight, right? This frictional force is not dependent upon the weight. Okay. Am I correct or did you understand that point?
Sir, can you repeat it?
So in this case, this frictional force, limiting friction is not dependent upon this weight. In this case,
Yes, sir.
right? This is balanced by this mg, but this is not equal to, because in here FL would be how much? This would be mu L n, and this would be mu L and F that you are applying. So in here you can see that this is not dependent upon this mg. Okay.
Yes, sir.
So in this case, this is dependent upon the heaviness. In this case, this is not. So I will do this question and then it will become more clear. Okay.
Okay, sir.
So we will see the example of this question. Okay. So now the question is that you have an object, right? This is again, let's say 5 kg, right? And the force that you are applying is, let's say 40 Newton, right? So you have to calculate, and let's say you have to calculate mu L is given. Coefficient of limiting friction is given 0.5 and coefficient of kinetic friction is given 0.3. So first thing you have to calculate is that what is FL. Second thing you have to calculate is that what is kinetic friction. And the fourth thing is that you have to calculate which friction is acting. Which friction is acting on the object. Okay, so please calculate and tell all these parts. Oh, so I've already got FL is 25. So Amna is saying that FL is 25 Newton and FK is how much? And the question is that which friction will be acting on that object? So RK
Sir, I
Rishita
also got 25 Newton FL.
So I got FL as 25 and FK as 15.
15. And oh, so Elham got FL 25 and FK 15. Rishita, what about you?
Sir, I didn't get it this time.
No, so okay, so we'll do the problem. FK, so Amna also got 50. Right, good.
I don't know about the third question.
Third question. Okay, so let us calculate FL. FL is what? Mu LN, right, Rishita? And N is what? This is N, which is equal to 5G. So this is 50, right? So N is
Yes, sir.
50 Newton. N is 15, so 0.5 into 50. So this is 25 Newton. Okay, so everybody is correct. And then Fk. Fk is mu k and then N. So mu k is 0.3 divided by into 50. So this is 15 Newton.
15.
Right. Now, the question was that which friction is acting on the object. So to find out that, we have to figure out what is object is moving or not. If it is moving, then it will have kinetic friction. If it is not, then it will have static friction, right? So
Yes,
Yes,
sir.
the object is pulled by 40 Newton. So FL is smaller than 40 Newton, right? This is smaller than F. So
yes, sir. So it's moving means it's kinetic friction.
absolutely right. So which means that the object is moving, which means that it is experiencing FK. Okay, understood everyone?
Yes, sir.
Yes, sir.
Okay, and if I ask you that, if I ask you what is the acceleration, guys? So can you guys calculate that?
Okay.
Because it is moving, right? Whenever the object is moving, then we have what?
Acceleration.
Right? Then we have, yeah, then we have Newton second law, right? So
Is it 3?
3 meter per second square. So the vertical part doesn't have any acceleration, right? And in the horizontal part, the free body diagram says that we have Fk. In this direction, we have F. And in this direction, we have Let's say this is 40 Newton. And then this is the acceleration. So if I write F net, this is MA. So F net is how much? 40 minus Fk, which is M is 5 and A. So this is 40 minus Fk was how much? 15, and then 5 into A. So this is how much? 25 equal to 5A. So this is 5 meter per second. Well, yes. Understood, everyone?
Yes, sir.
Yes, sir.
Okay, so you guys have already did this problem. So now let us understand Elham's question. So we'll do a question and then we'll understand that.
So can you scroll up one bit? I want to copy the acceleration.
Oh, okay. So please.
Done, sir. Thank you.
Okay, so we have to do two problems, right? Let us do the Elham's question first, and then right. So again, mu L is 0.5, mu K is 0.3. So you have this surface, right? And there is some object, and you are applying a force. Let's say 20 Newton, and this is oh, which one? Now it is experiencing, right? It is experiencing limiting friction in this direction. Okay. Or if it is moving, then it is experiencing a kinetic friction. We have to figure out what is the friction that it is experiencing. And it is, so let's say the mass of this object is 5 kg, right? So it is also experiencing a weight, which is 5g. Okay. So you guys have to calculate that will the object will remain here or it will drop down. So what you are doing is that you have this wall, right? You have this wall, and let's say my force is if my force is not strong enough, so it will drop, right? It will drop. But
Yes, sir.
my force is enough that it is holding or it is balancing the friction. So I have to figure out how much force I need to apply so that it sticks to this wall, right? So this is the question. And you guys will see that this limiting friction is dependent upon this object or this heavy object or not. So yeah, you guys please calculate FL and FK. Please calculate that and tell me whether the object will move or not. So what is the force which is moving the object? Can you guys tell me?
Sorry, sir.
What is the force that is moving or that may move the object? What is that force?
Gravitational.
Gravitational force. Good. So we have to compare the friction with what?
Gravitational force.
Gravitational force. Absolutely right. So you guys have the idea, exactly correct idea. Please calculate and tell.
Yes, sir.
So one moment, guys. Okay, FL you are getting 25 Newton and FK 15 Newton. So FL 25 Newton. Oh, RKB is getting RKB is getting FL 25 Newton, FK 15. Okay. So Rishita and Elham and Amna, what about you guys?
Sir, I got FLS 25 and KF 15.
So got the same result, Elham and Amna. So somebody has.
Yes, sir, even I got same.
Okay, everybody got the same. So this one has majority. Good. All the people are agreeing to this answer. So what is FL? That is mu L N. And we have to figure out what is N in this case. So N is this, right? Which means that this is not moving in this direction, right? Which means that N is equal to 20 Newton, right? So we have 0.5 and 20. So 10 Newton.
Sir,
Yes.
how come N is 20 Newton if it is in opposite direction?
So is the normal reaction in this direction or in this direction? Where is the normal reaction? Where are the surfaces touching?
On the left side.
Yeah, on the y part, right?
Yes, sir.
So perpendicular to y, that is x, right? What is the perpendicular to this surface? So these surfaces are touching, right? So so this is applying some force, this is applying some force. So the force applied by this surface perpendicular to this is this, right? That is called the normal reaction.
Okay, sir.
So this I discussed in here when I was discussing, yes, that I, okay. So this would be, all of you guys understood why this N is 20?
Yes, sir.
Okay,
Yes,
and
sir.
then this is 0.3 and N is 20. So this is 6 Newton, right? Now, to have the motion of this object, right? To have the motion of the object, so the motion of this object is given by this gravity, right? This gravity is making this object to move. So then we know that this FL is lesser than this, what is that? This is 50 Newton, right? Which means that the object will move, right? So you guys
Yes,
saw
sir.
that, yeah, you guys saw that this friction is not dependent upon the heaviness of the object, but the movement is dependent upon this weight, right? Motion is dependent upon the weight, but this friction is not. So this object will move, right?
Yes, sir.
Object will drop down, and friction is Fk, which is 6 Newton. And if I ask you guys to calculate the acceleration, so can you guys calculate the acceleration? Oh, which friction did I use to calculate the Fk? Okay, so can you guys,
FX, sir.
yeah, can you guys calculate the acceleration? Where the acceleration is happening?
Okay, sir. So downwards, right?
Downward, downward. So A is down. So please calculate the acceleration and tell.
Okay, sir.
Question is what would be acceleration? So just make the free body diagram. Then you have your answer. This is 5 kg, 5g, fk, and acceleration. Because this part will not contribute. This is balanced. So guys, what the answer? Amna got 3 meter per second square. Okay, what about Rishita, Akif, and Ella? Yes, guys, this is a simple free body diagram question. Numerous times you guys have solved this question.
Yes, sir. I'm getting 8.8.
8.8. So whatever you guys are getting, 8.8. Oh, so this is Akif. Akif is getting.
Sir, I'm getting 4 meter per second.
Okay, so we have a totally degenerate or totally different answer. Rishita,
Sir, I'm getting 6.
oh, so no agreement in any of the answer. Okay, so FK is 6, right? So this is, if I write F net, this is MA. So what is positive? 5G. 50 minus, what is that? 6. And this is 5 into 8. So this is what? 44 divided by, oh, so I can see that Akib is correct. 8.8. Yes, everyone understood.
Yes, sir.
So what did you guys do? What did you, where did you get the wrong answer?
The division.
Oh, it is in the,
I got it in the division. I got it wrong.
oh, division part. Okay. So, yeah, so the equation part, everything got correct, right? Everyone correctly wrote the equation,
Yes.
right? Good, good. So, okay. Now my question is that what if I, uh, so you see that when I apply 20 Newton force, right? When I apply a 20 Newton force, So the friction becomes 10 Newton. Now, when I apply, let's say, when I apply, so this is 5 kg, and when I apply a 60 Newton force, right? When I apply a 60 Newton force to this object, so now can you guys tell me what would be FL?
Okay, sir.
Yeah, so this would be, let me tell you. So this is 0.5 into 60.
60.
So again, this is 30. Oh, so I have to
30 Newton.
let me increase this one again. So, okay, so let's say this is 120 Newton, right? So this is 0.5 into 120. So this is 60 Newton. So you guys can see that my friction force is depending upon what? The force that I am applying to this object, right?
Yes, sir.
So now the frictional force has become, if I apply a 120 Newton force, the friction force will become 60 Newton. So will this object move? Because in this case, it was dropping down. So in this case, will it drop down? Because my F is how much? 50 Newton. So now my FL is greater than 50. So this object will not drop down, right?
No, sir.
Understood, everyone?
Yes, sir.
So in this case, what we saw that this is friction is not depending upon this heaviness of the object. So now let us do one more question, which is so this question everybody knows, right? So now as Elham was asking, right, in the yesterday's class. So what happens? Okay. So what happens when we have a friction on this surface? So this is 37 degree, right? This is 37 degree. Mu L is 0.5, mu K is 0.3, and you have put an object. And let me also write this as cos 37 is 4 by 5, and sine 37 is 3 by 5. So, and I have put an object, and it is of, let's say, 5 kg, right? And you guys have to calculate that whether this object will slide down or not. Will this object will slide or not?
Okay, sir.
Everybody understood the problem?
Yes, sir.
Okay, so the question is that uh, will this object slide? Or to do that, to check that, you guys have to calculate first. You have to calculate FL and you have to calculate FK. So these two things you have to calculate. Or you can only calculate FL and but you guys please calculate both these quantities. This friction will be completed and then we are left with only uniform or dynamics of circular motion. So we'll study bank routes and we'll study the sliding or that kind of question in the bank route or in the simple. So if we are able to understand these part in friction, then that dynamics of circular motion will be easy. So
So I got FL and FX value.
yeah, so what did you get, Akif?
So for FL 25 Newton, FX 15 Newton.
25 Newton again.
Yes, sir.
So remember, this is an inclined plane. So
Sir, for Newton will be like upward side. The
yeah, so the normal reaction is not like this. It is
it was perpendicular.
this, right? This is the normal
Yes,
reaction. And we have drawn the, okay, so we'll check. And you said Fk is 50.
yes.
Remember the free body diagram of inclined plane. Yes, Rishita, Alana, what about you guys? Yes, guys,
So I got 20 for FL.
20 for FL. Okay. So Rishita got FL equal to 20. Again, we have a disagreement, right?
Sir, even I got 25 and 15.
25 and 15. So again, we have an agreement and a disagreement as well.
So I got 12 for FK.
FK is 12. Good, good, everyone. So, and what is Amna? FN 25 and 15. Okay, so let us see. So we have to draw the free body diagram. We have to write all the forces. So one is this normal reaction, right? And other one is this gravity. This is downwards, right? So then this will have two components. This is theta. So this is mg cos theta, right? And then this is mg sine theta. Okay. And in this direction, we are experiencing the friction. So the friction FL would be mu L and N. So N is how much? From this diagram, N is how much? Hmm.
So should
Everyone,
we take n is equal to mg cos theta?
mg cos theta. Yes, absolutely right. Mg cos theta. Everyone agrees to this answer, right? Right,
Yes.
everyone. So we have mu L, which is 0.5, and M is 5, G is 10, and cos theta, cos of 37. So this is 0.5, and then 5, and then 10, and then 4 by 5. So this is canceling, and 5 into 0.5, 0.5 into 10 is what? 5 into 4. Okay, so this is 20. Right, guys? Correct,
Yes,
sir?
sir.
And similarly, what would be Fk? So Fk is 0.3, and 5 into 10 into 4 by 5. So this part cancels. This is 3, 4s are 12. So 12 meters. Understood, everyone?
Yes,
Yes,
sir.
sir.
So now we have this 20 Newton, and did you guys not break the components? Yes. So that is why this is inclined plane. That is why I was yeah. So I was talking about this inclined plane, right? I was emphasizing on that inclined plane part. So Fk is 12 Newton, and you guys tell me that which component or what part will what what ball will contribute to the sliding part. So what will contribute to the
mg
slide?
sin theta?
Mg sin theta. Absolutely right. Good. So Mg sin theta will contribute to the sliding part, right? So we have to check the limiting friction with Mg sin theta, right, everyone?
Yes, sir.
So now
Yes, sir.
let us calculate. Good, everyone. So that is what I want. You guys calculate, and then yeah, you guys see that what was the idea. So mg sin theta is what? Mg sin theta. So 5, 10, and 3 by 5, right? So this 5 cancels, and we have this 13, right? So you guys see that this is 30 Newton, and this is FL is 20 Newton. So will this object slide? Yes, everyone.
Yes, sir.
Right? So it will slide. Yes, it will slide. It will slide, and why? Because FL is lesser than this F. Okay. So you guys first note it down, and then I will ask you guys to calculate acceleration. So that is why this mu L and mu K are important, because whenever we calculate motion, then we have to use this one. Whenever we have to check whether motion is happening, so we have to take this one. That is why these two are important. You guys first note it down, and then tell me about the acceleration.
Finished, sir.
Finished. Okay, everyone noted?
Yes, sir.
Yes, sir.
Okay, so you guys please calculate the acceleration of this object.
Sir, I'm getting 7.6 meter per second square.
So Archive is getting 7.6 meter per second square. And Rishita Elham, right? And what about you guys?
Sir, I'm getting 7.7.
Yeah, 7.6, 7.7 is the okay. Elham and Amna, what about you guys?
I got 7.6.
Okay, so 7.6 and Amna, what about you?
Sir, 7.7.
Okay, so all these answers are right. So these are nearly same. Okay, so we know that this is mg sine theta, right? And this is acceleration and this is fk. So this was f net is ma. So f net was how much? F net is mg sine theta, which is we have already calculated 30 minus fk, we have already calculated 12. This is 5 into 8. So this is how much? 18 by 5, and A is what? So what is it? Huh? What did I? Okay, how did you guys get? Yes,
Sir, I did 50 minus 12.
50 minus 12.
12. Yes, sir.
So this, which part is responsible for the acceleration? This part, right?
Yes, sir.
So due to this, the object is sliding. So
Okay, sir.
so we have this mg sine theta, which we have calculated 30 minus 12, and so this is 18 by 5, which is 3, and point how much? Okay, so 3 6. So 3.6 meter per second square. Right, everyone. So where
Yes,
did
sir.
where did you guys get the wrong answer?
I forgot to subtract it.
Oh, so yeah, always remember, right? Always remember the sign convention. Okay, so you guys please note it down, and then this friction would be over. We have one more question, but I will, yeah, I want you guys to try that question. Okay, Every question you guys there tried, right? So this question is not different, but noted this part, everyone.
Yes, sir.
That's
Finished.
right.
Okay, so the next question is from the NCRT. So I have that. So let me bring that in here. But the time will be over, so I will just show you guys what happened. Okay, so I will just show you guys the question and you guys try that question. Okay, and today also you guys will have, so you guys have the class assessment. So please, yeah, log into that account and, but before, let's just see that question. Why is it taking so much time? Yes. Yeah. Uh, this question, right? So this question you guys have to calculate. Okay, 4.9. So please try this question at your home. Okay,
Okay, sir.
right. And so then we have this next topic is circular motion. Then this would be over. So then this chapter would be over because this part we have already done. Free body diagrams we have done numerous questions. So then this would be over. So you guys please log into your Learnivio account and then start the active test. Okay. And whenever you guys find that active test, please tell. Yes. One question. Okay. Yes, Akif. What is the question? Not related to studies. Oh, so yes. Yes, sir. What is the question, Akif? Yes. Don't hesitate. What is the question, Akif? Oh, did you? Yes, yes. I watched that. Yes. So you saw the download section. Okay, yes. So I have a, I am a huge anime fan. So that live action, I like that part. Yes. So yes. Okay. So did you guys get the? So have you watched? Oh, good, good, Aki, good. And did you binge watch episode by episode? How did you watch? Okay. In one go, or did you watch episode by episode? Okay, so you took time to watch. I watched the whole one season in one go because that is what you did. Good, good. But exams are coming, Yaqib sir, so you have to also prepare for the exams. Okay, so Elham, Rishita, and Amna are here, so we should not waste their time. Yes, did you guys found the or find the active test? Rishita, Elham, and Amna, and Akib, you too. Did you guys find that active test?
1 minute, Sam. Opening.
Okay, please find that
Sir, even I'm finding.
more than 6 months and also not finished. Oh, you are talking about the series. So series is very long. 10. Yeah, Rishita, what did you say?
Nothing, sir. I just said I was waiting.
Oh. Okay, so all of you guys got the. Oh, we'll talk about that, Akib. In spare time, we'll talk about that. So all of you guys got that assignment?
Yes, sir.
Okay, so you guys can leave